Circular motion, previous the tutor. Convert the following to other angular measures. So we are converting 28 degrees to revolutions, and we're also converting 1/4 revolutions per second to rads per second. How do we do this one? All right, so if we want to convert 28 degrees to revolutions, we are going to use dimensional analysis to do this. So how do we do this one? So we're going to say 28 degrees, right? We are converting to, remember, revolutions. So 1 revolutions is equivalent to what? To 360 degrees. So this degree and that degree gone, and let's divide 28 by 360, right? So I'm getting 0.078 revolutions. That's all. Let's convert this one here. So we're having 1/4. Now 1/4 is the same thing as 0.25 is fine. So we have revolutions per second means over second. Then we are converting to rad per second. All right. So if I have to convert this one to rad per second, I know that 1 revolution, since there's a revolution on top, so I must have a revolution down here. Then what should I have here? I'm going to have what? Like that. I need to have a rad here and a second. So a rad will be there because one revolution in rads is actually 2 pi. So what do we get? Revolution gone. So I will remain the rad per second. So which is 2/4 should give us 0.5. So we are getting 0.5 pi rad per second. The next one we are going to convert is okay, let's convert 2.18 rad per second squared. I want us to convert this one to revolutions. Let's convert this one revolution to second squared. It's very easy. All right, just take your time. You get there. So we're going to write 2.18. We're going to say rad over second squared. That's what this means. That means for us to have a revolution here, what should we have here? We are going to have a rad down here so that it can cancel with a rad on top. So we're going to have 1 revolution on top there. We must have a rad here. 1 revolution in rads is actually 2 pi. Like that. Rad gone. So we end up having 2.18 divided by 2. All right. Which will just give us by 2 pi, sorry. So we divide 2 pi into 2.18. We can do that. All right, so I'm getting 0.3. I'll round it off to 2 decimal places only. Sorry, to 3 decimal places. Yeah. So we get revolution per second squared. That's all. All right, so here is a scenario. So we have, this is just a rod like that, where we have attached a bob of a pendulum, and the string is 90 centimeters long, and you can clearly see that the arc which is being made by the same bob is 15. So it's like it's a circular motion kind of stuff. So it is making this type of movement such that from there where it starts from and where it ends there, the distance is just 15 centimeters. So this is just the arc length. So how do we find theta in radians and as well as in degrees, given that the arc length is 15 and the length of the pendulum is what? Is 90. Now, take note that the length of the pendulum is just coming from the center all the way to the what? To the circumference. So that is just the radius. So for us to find part A, take note that the length here of the pendulum, sorry, the arc length, let's call it that, is just equal to radius times theta. This is what we have always done in mathematics. So we're looking for theta. So we're going to say L over R. And our L is here, and our R is there. That's all. So we are just putting L is 15 centimeters, and here we've got 90 centimeters. All right, so centimeter cancel. Take note the answer that we're going to get. Okay, so 15 we divide by 90. Sorry, 90. I'm getting 0.16666, but this will be 0.167. Is this in radians or in degrees? So actually this is in rads. If you use this formula to find the arc length, you are actually finding the theta in what? In radians. And what about B? Since we know that we have that in radians, how do we convert from radians to degrees? So the theta in degrees will just be equal to the angle that we've gotten in radians. Okay, then we need to eliminate the radian here, so there must be a radian here, and the one revolution is actually 2 like that, and here we're going to have 360 degrees like that, so that we can eliminate this part and that part. So what do we get? I'm getting 9.6 degrees. That's all. That is so. Well, I hope you enjoyed this one. A fan turns at a rate of 900 RPM. RPM means revolutions per minute. All right. A says find the angular speed of any point at one of the fan blades. B says find the tangential speed of the tip of the blade if the distance from the center to the tip is 20 centimeters. So the fan is rotating, but at the rate of 900 revolutions per minute. How do we find the angular speed? Now, remember that for us to find angular speed, right, which is given by this symbol, we said this is just the change in what? The angular displacement over the change in time. But this we do not have, all right? In fact, we don't have the actual degrees, but we have the rate. And remember we said angular speed can also be found by what? 2, remember, pi f. Do you remember? Where this one is a completely, when the fan is rotating, it is rotating completely like 360. So this will be 2 pi. You get the concept, right? And we said if you can distribute change in this, then you say 1 over change in time. This is just the period. 1 over period gives you frequency. So what we've been given here, the frequency is just what? 900 revolution per minute. So this is our frequency. Are we together? Now that we know the frequency, we can, if you want, we can convert this one into seconds. All right, we can do that because we know here we can just substitute with what? 60. So we'll be getting 15 revolutions per second. So this is revolutions per second, right? I've just converted by dividing 60 into 900. All right, now since we know this formula, let's go on and proceed. This will be 2 pi, and we can put our frequency there, which is 15 revolutions per second. So what do we get? So we are getting 2 pi multiplied by 15. I'm getting 94.2477 like that. So I'll leave it to 94.2 rad. Now these are already rads now. By virtue of multiplying by 2 pi, they are no longer revolutions, they are now rads. So this will be the angular what? Remember we said the units for angular speed is actually rads per second. Now B says how do we find the tangential speed? Remember the relationship between the tangential components and the circular components. We said we can actually find, we said tangential velocity is the product of the angular velocity and the radius itself. All right, so we've just found 9.42, 9.4, sorry, 0.2 rad per second. We multiply by the radius, because that's what they're saying is 20 centimeters. Find the tangential speed of the tip of the if the distance of the from the center to the tip, which is the center all the way to the tip, that becomes our radius, is 20 centimeters. So we need, because here we have we already converted, we need those, remember, is meters, standard units of length, so that should be meters. So dividing by 100, we get 0.2 meters, right? Then we can do what? Do the multiplication. Okay. So what do we get? 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 0.2. So I'm getting 18 meters per second. That's all. You're done. You are done. All right. So thanks so much. We'll meet again in another tutorial.